Hi, Assalamualaikum. Today we're going to learn about polar coordinate systems. So what are polar coordinates? Suppose we have this axis. So we call this as a polar axis, with the origin being called as the pole. Then we want to denote the coordinates in polar system with r theta. We call the point P r theta, where r here represents the length or the radius, the length from the pole, and then the theta is actually the angle that the coordinate makes with the polar axis, meaning to say that we measure this line from the polar axis. Alright, so that is theta. Now we need to recall that if pi radian is actually equal to 180 degrees, 2 pi radian is actually 360 degrees, and so on. And then suppose we have this point r theta in polar coordinates, then if we have like, okay, so we know that this is r and this is actually theta. All right, so if we extend the line on the opposite side, so right, so we know that if that is angle theta, then this one should be theta plus pi. Alright, meaning to say that we add theta with 180 degrees, so we get the line which is opposite to that r theta. So we can denote this point as r theta plus pi. Alright, so next, suppose we have this polar coordinates r theta, and if I have, like, for example, this one is r, okay, this one is r, that one is angle theta. So if I extend that line with the same length of r but in opposite direction, so we call this as negative r. So we can say that this point is actually negative r theta. So let's look at example 1. Suppose we have to plot the polar coordinates 1 pi over 4. So we know that this 1 is r and pi over 4 is the theta. So the length of that line is 1 and pi over 4 is the angle that is made from with the what do we call polar axis. So we have this polar axis with the pole at the center. So we have the length here is 1 and the angle made with the polar axis should be pi over 4. Right, pi over 4 should be 45 degrees. Okay, so alright, so we label that point as 1 pi over 4. If we have, like, for example, this one is pi over 4, then if we add pi over 4 with pi, we'll get 5 pi over 4. So this one is actually the coordinates for 5 pi over 4. If we reverse, okay, since this one is the coordinates for 5 pi over 4, if we reverse for the radius, if the radius here is 1, so of course this one should be negative 1, the other way, the other side, you know, the opposite side. So the coordinates for this one is actually negative 5 pi over 4. Right, we can also write in another form. Suppose we have this, what do we call polar coordinates, means, for example, this one is actually, right, the angle here is actually pi over 4. So if we rotate it once, meaning to say that we start here and then we go back to here, alright, so we add pi over 4 together with 2 pi, so we will get 9 pi over 4. Okay, so it's actually the same thing, which is 1 pi over 4, or this one, since we rotate it once, so it will become 9 pi over 4, which is pi over 4 plus pi. Okay, so we can also write, okay, suppose we have this one. How do I get this one? Negative 3 pi over 4, because the angle theta is measured based from the polar axis. So if it is negative, so it goes clockwise. So this is actually negative 3 pi over 4. Since I want the other way around, right, so I want this line over here, so of course that one should be negative 3 pi over 4. Right, negative 1, negative 3 pi over 4, because this is 1, so this should be negative 1. So negative 1, negative 3 pi over 4. So there are many ways of writing the 1 pi over 4. Right, we can write this form, or you can write this form, you can write this form. If you want to write it twice, also okay, meaning to say that you add 9 pi over 4 with 4 pi, all right, something like that. Suppose we have to plot the polar coordinates given by 3 pi. So this one is radius r, and this one is the we call theta. So we start with drawing, with sketching the what do we call the polar axis. We know that 3 pi is actually, if you calculate using your calculator, all right. So 3 pi, okay, if you go, okay, pi over 2 pi, 3 pi over 2, so you get 2 pi. So what about 3 pi? So you go again, pi, sorry, yes, pi over 2, and then you got pi. So 2 pi plus pi will become 3 pi. So meaning to say that this is a line with the length which is 3, all right. So this is 3, but the angle that is made from the polar axis is actually 3 pi, because pi plus with 2 pi, right? So this is the coordinates, which is, all right, that one is angle 3 pi, and this is the coordinates 3 pi. Right, so in general, the following r theta is actually equivalent to what do we call this one, r theta plus 2k pi, with the condition that k is any integer. Integer can be -2, -1, 0, 1, 2, 3, and so on. All right, this one also -3, -4, and so on. So it can be any integers here. So if you substitute, then it will be the same thing. So r theta is equivalent to r theta plus 2k pi, or -r theta plus 2k pi, 2k plus 1 pi. All right, you can try this. Right, now we try to make the relationship between the polar and Cartesian coordinates. Cartesian coordinates is the one that we learned before. We have x-axis and y-axis, and we know that they, sometimes Cartesian coordinates are being called the rectangular coordinates. So, all right, let's consider these x-axis and y-axis. In this case, we assume that on the x-axis is actually the polar axis. So we try to plot the polar coordinates p, r, theta. All right, we know that this is r, and theta should be the angle that is made between what you call the polar axis with the line, the orange line there. So now if we extend this line to the x-axis, so we know that this length is actually x, and this length is actually y. So you have to recall the one that you learned before in the basic mathematics, I guess. Okay, sine is actually opposite of a hypotenuse, cos is actually adjacent of a hypotenuse, and tangent is actually opposite of a adjacent. For the identity, we have to recall the tangent is actually given by tangent theta is given by sine theta over cos theta. So TSC, tangent sine over cos. Right, so now we can make relation between x, r, and y with theta. How do I do this? Right, suppose we start with cos theta. Right, you will see this cos or sine. Okay, cos theta. You can start with cos theta. Cos theta is given by adjacent over hypotenuse, because we have ja here. So adjacent over hypotenuse, so x over r. So we have cos theta, which is given by x over r. Right, so what about if we want to make a relation with using the sine theta? So sine theta is actually so you have to use this opposite over hypotenuse. So opposite over hypotenuse, so should be sine theta, which is given by y over r. We can rewrite this, all right, by multiplying r to the side, all right, and also for this one, so x is equal to r cos theta, and y is equal to r sine theta. So now, if we try to, we try to make another relationship. Suppose we square both x and y, so we add them together. So we'll have x squared plus y squared should be this square plus this square. All right. So we try to factorize r square, and then we have something like this. So we have to recall that cos squared theta plus sin squared theta should be equal to 1. So we have x squared plus y squared equal to r squared. Right. And last one, we can make a relation using the tangent theta. In this case, tangent theta, right? You can use your what we call this diagram also. Tangent is actually opposite over adjacent. So opposite over adjacent, y over x. So we have tangent theta is equal to y over x. So you have to remember this one so that you can convert from the polar to Cartesian and Cartesian to polar. All right, so let's look at this example. Suppose we have to convert these polar coordinates from 4 pi over 6 into Cartesian. So we need to recall that 4 is actually the r and pi over 6 is actually theta. So what do? We have x is equal to r theta, with r being 4 and theta being pi over 6. So we substitute inside this formula, we get this one. And the same thing for y equal to r sine theta, we substitute with 4 and pi over 6, so we get this value. How do I get this? Alright, so to do this, let's just recall. We have two important triangles for the trigonometric ratios. The one that we start with 1, 1, right? We start with drawing 1, 1. So of course by Pythagoras theorem, you got the hypotenuse as square root 2. Alright, so we know that the angle that is made between here, because this is isosceles triangle, so it should be 45 degrees. So that one is actually pi over 4. Alright, another triangle is start by drawing 1 and 2, but this one is for 1 for this one and 2 is for the hypotenuse. You start drawing that. Of course, the other side should be square root 3 by Pythagoras theorem. So we want to label pi the angle 60 and 30 degrees, or in radian should be pi over 6 and pi over 3. So the one that is smaller here should be pi over 6, this one should be pi over 3. So we label it pi over 6, that one is pi over 3, and this one is pi over 6. Then using Sohcahtawa, you can make relation using sine, cos and tangent. Alright, in this case I don't show the tangent, but you can see here that sine, cos for pi over 6, pi over 3 and pi over 4. You can make relation here. Right, so that's how I know cos pi over 6 is actually root 3 over 2. Alright, so that's how you do it. Alright, so now we already have the what do we call x value and y value, because it is from polar to Cartesian, meaning to say that we have to write in form of x and y. So our Cartesian coordinates should be 2 root 3, 2. Alright, this one is for x and this one is for y. Now let's look at this example. So now, just now we see from what do we call from polar to Cartesian coordinates, but now we are going to convert from Cartesian coordinates into polar coordinates. So how do we do this? So we know that this is actually x and y, and we have the relation that r square is equal to x square plus y square. Bear in mind that for polar coordinates we have to write in form of r theta, meaning to say that we have to find the r and also theta. So r square is given by x square plus y square. X is 2 and y is negative 2. We substitute it here. So we calculate, we become r square equal to 8. We have to find r. R should be root 8, which is simplified to be 2 root 2. Alright, now we want to find the angle theta. Right? So we have the relation that tangent theta is equal to y over x. So y is negative 2 and x is actually 2. We simplify, it become negative 1. So to find the angle theta, we have to take the tangent inverse. So we got tangent inverse of negative 1. If you use your calculator, it will become negative pi over 4. Alright, tangent negative 1. Alright, now if you use what we call a radian, right? So you should it should be pi over 4. But why is it negative? Alright, so I get these two values actually, negative pi over 4 and 7 pi over 4. How do I get this? Later I will explain. Alright, so this one is negative because, alright, let's just recall our rectangular coordinates or Cartesian coordinates to negative 2. Where is it? It's actually 2, negative 2. It's somewhere around here. So of course when we draw this line, right, so this is the line to negative 2. The length here is actually 2, alright, 2 root 2, alright, 2 root 2 is the radius, but the angle is the one. We recall that theta is the angle that is made between this line with the, what do we call, polar axis. Which one is polar axis? Of course this one. So this one is the polar axis, so we have to make the angle theta with that line. Alright, so of course this one is the angle theta. Since it goes clockwise, so this one should be negative pi over 4. Another one, how do I get 7 pi over 4? So 7 pi over 4 is actually this one plus with this. Alright, so from this to this is actually 7 pi over 4. Okay, 7 pi over 4. So our polar coordinates are, alright, 2 root 2 negative pi over 4 or 2 root 2 7 pi over 4. Okay, it can be two answers here. Right, now we need to see what are polar curves. Alright, so graph of polar equation, alright, which is given by r equal to f theta, are made up of all points which have at least one polar representation whose coordinates satisfy the equation. This one is actually the polar curve. What do I mean by this? Let's see this example. What curve can be represented by r equal to 1? R equal to 1. So it's actually a circle. Why do I say that it's a circle? Because suppose at this point, this one r is the radius is 1. We don't mind now theta is a pi over 6, pi over 3, or whatever values of theta. We don't mind. Now what's important, now it satisfies this equation, which is r equal to 1. Suppose I want another point here, right? So of course this one r is equal to 1, the radius is 1. So what about this one? Of course r equal to negative 1, r equal to 1, right? So if we get this line, alright, r equal to 1, so this point also r equal to 1, since its radius is 1 from the pole, right? So since it satisfies for all these points on the circle for r equal to 1, so it's actually a circle. And we need to note that polar equation with r equal to k is actually a circle with center 0 and radius k. Why do I put modulus k here? Because if you are given with r equal to negative 1, then it's the same, right? So suppose this is r equal to 1, then r equal to negative 1 is over here. If r equal to 1 over here, so r negative 1 is over here. So it's the same thing here, alright? So you have to take modulus here. So it's a circle, bear in mind. Next, what if we have polar curve given by theta equal to pi over 3, right? Suppose we have this, what we call polar axis with the origin or the pole here. So we have the angle pi over 3, which is 60 degrees, right? All right. So 60 degrees over there. So where are the points with the angle 60 degrees here? Suppose I want to have, okay, polar coordinate negative 3 pi over 3. So of course we have here. What about when r equal to negative 2? Of course, negative 2, what do we call? Pi over 3. Negative 1, right? For r equal to 1, right? Suppose for r equal to 1, so something like this. For r equal to 1, so still it's on this point. R equal to 2, r equal to 3. So if we see these points lie on a straight line here, right? So no matter where the radius r, the length is, so the angle here is still pi over 3. Alright, so the angle is pi over 3 no matter radius is how long. Alright, so that's a straight line. So bear in mind, if we are given with theta is equal to some angle, so that's actually a straight line. Right, now we try to sketch the curve with polar equation. Alright, I equal to 4 cos theta. This is quite different, right, from the other examples. Firstly, we need to recall that cos theta is given by x over r. So now we have the r, alright, so this is r, and 4 cos theta is actually x over r. So we substitute cos theta with x over r. We need to simplify this. We get r squared equal to 4x. And we need to recall that x squared plus y squared equal to r squared. So we substitute r squared with 4x here. So this r squared have become 4x. So we have this equation x squared plus y squared equal to 4x. If we see this, alright, so we need to recall some other equations of graph that you have learned before. X squared minus 4x plus y squared equal to 0, so that make it in general form. Now we have to, what do we call it, try to add 4 on both sides. So I add 4 on the left side and also add 4 on the right side. So we try to factorize this one. We'll get x minus 2 square, right? Since y is alone, so y minus 0 square, 4 can be written as 2 square. What equation is this? If you remember, this is actually the equation for the circle, because the equation for the circle with center hk is given by x minus h plus y minus k square with the radius r, so r square. So this is equation for the circle. In this case, the center is actually 2, 0. Alright, so 2, 0, radius is 2. So we try to draw this circle on the, what we call, on this plane, right? So we have this circle. We know that this is center 2, 0, and the radius is actually 2. If we add 2, so we get 4. We minus 2, we get 0 here. We add 2, we get 2 there, and then we add minus 2, we get negative 2. So that is your circle. All right. So you have to play around with the examples, and then you see what shapes they are. Alright, let's now look at this example where we have to sketch the curve for r equal to 1 plus cos theta. But firstly, let's recall how the graph of cos theta looks like. So this is for the cos theta, where this is here is 1, 0, and negative 1. But now we want 1 plus cos theta, so it be shifted upwards by 1 unit. So the graph looks like this. Alright, so to draw this, to sketch this curve, so we can divide into several parts, where the first part is here, which is from 0 to pi over 2, and the second part from pi over 2 to pi, and then from pi to 3 pi over 2, which is the third part, and finally for the fourth part, which is from 3 pi over 2 until 2 pi. Right, so let's focus from 0 until pi over 2. Right, so from when theta is from 0 until pi over 2, we can see that when it is 0, so the y-axis is 2, and which is r is 2, and for the pi over 2, all right, when theta is pi over 2, so r should be 1. So it is from 2 to 1. So how to draw? All right, so we have to identify which are the theta which is also 0 and also pi over 2. So from this axis, so we have theta equal to 0 over here, and theta is equal to pi over 2 over here. So to draw it, we know that it is from 0 until to pi over 2, so r makes from 2 until 1. So 2, like suppose it's here, and 1 and it's here, so it be something like that, right? Something like this, right? So we will have this curve, all right? So from 2, where the value is here is 2, and this here is 1, something like that, all right? So now we can go to the second part, which is from pi over 2 to pi, right? So for theta from pi over 2 until pi, we know that the value of r, which is on the y-axis here, is actually 1 until when pi, so it becomes 0. So from 1 to 0. So we know that it is pi over 2 over here and pi over here. So we have to start at 1 and ends at 0. Where is the 0 for this what we call polar coordinate? So of course 0 is here, the radius is 0, right? So we have to go to the pole, all right, something like that. So we will have this curve, all right, and next we can move to the third part, which is from pi until 3 pi over 2. So we can see that from pi until 3 pi over 2, so the value is from 0 until 1, all right? So from 0 until 1, so meaning to say that we have to identify first from pi until 3 pi over 2. So it starts at 0, it goes to 1 on the polar for the 3 pi over 2. So it goes to there, all right, something like that. So it goes from 0 until 1, and then finally we can start from 3 pi over 2 until 2 pi, so it's from 1, right? It's from 1. At 2 pi it's at 2, so 1 to 2. So the r from 1 to 2, so we know that this is actually 3 pi over 2 and this part is actually 2 pi, so it starts at 1 and it ends at 2, meaning to say that you go back to this curve, something like that. So you will have this curve. So this is called as cardioid. Alright, so cardioid. You can try for r equal to 1 plus sine theta. Alright, now let's look at example here where we have to sketch the graph for r equal to cos 2 theta. So firstly we have to recall how the cos 2 theta looks like. So it looks like this, right? So since it's 2 theta, so we have 2 cycles here, alright, for the cos graph. 2 cycles within 2 pi, alright? From 0 to 2 pi it should have 2 cycles, so it will be something like this. So now we can divide this for sketching this graph, we can divide into 8 parts. 1 2 3 4 5 6 7 8, something like that. How do I do this? So we do it one by one. Suppose we consider the first region here, right, from 0 to pi over 4. So this is the first part, all right, from 0 to pi over 4. We see that it starts from 1 and it ends at 0, so it's actually from 1 to 0. So you go to 0 to pi over 4. We need to consider these two. Suppose we have 1 here, all right. I'll sketch for you. Suppose we have 1 here, all right, 1, and it should end at 0 on this graph, all right, because from 0 to pi over 4. So we have something like this. Okay, you draw it, okay, you sketch it, all right, something like this. So this is the direction, all right, so this is the direction. Now we need to consider the second part, which is from pi over 4 to pi over 2. So from pi over 4 to pi over 2, we have r from 0 until -1. So we know that from pi over 4 to pi over 2 is actually from 0 to -1. If it is from 0 to 1, it should be something like this, all right. We need to go this way, we need to go this way, all right. From 0 to 1, we know from pi over 4 to pi over 2. But since it's from 0 until -1, you know -1 is the opposite side of the polar coordinate, so of course should be here, right? Suppose 1 is here, so the opposite one, it should be here. So from 0 until -1, it should go this way, all right. So this is the direction, so not that one, okay. So this is for the first one, this is for the second one. Now we need to consider the third part, which is from pi over 2 to 3 pi over 4. So this is from -1 until 0. So we want to go from what we call pi over 2, right? So this is the pi over 2 from 3 pi over 4. So we goes from -1 until 0. So you know, you go back to this, right? So that is the for part 3. Now we have for the fourth part, which is from 3 pi over 4. This is 3 pi over 4 until pi. So we want to go from this to this. So we have that at 3 pi over 4 it's 0, and at pi is actually 1 here. So we have from 0 to 1. So we have now here from 0 we want to go to 1, so 1 maybe somewhere around there. So it goes this way, all right, something like that. So that's the direction, okay. All right, now we have for the fifth part, which is from pi to 5 pi over 4. Okay, from pi to 5 pi over 4 is actually from 1 to 0. So we have this one's for the fifth part, from 1 to 0. So from pi to 5 pi over 4, it goes from 1 until 0, it goes back to the pole, something like that. All right, so the sixth part from what do we call 5 pi over 4 to 3 pi over 2, which is from 0 until -1. I hope you get how do I write r from 0 to -1, right? From 0 to -1. -1 is over here, all right? This is -1. So now we, for 5 pi over 4 until what we call 3 pi over 2, from 0 to -1, again it should be this way, all right? It should be this way, from 0 to 1, but now it's from 0 to -1, so it's opposite side there, all right? So that's not this one. So we have this, what we call, we have this graph, all right, the path over there. Next we have for the 7th part, which is from 3 pi over 2 until 7 pi over 4, all right? So 3 pi over 2 from what do we call, from -1. So 3 pi over 2 should be over here, but it starts from -1. So -1 is the opposite one, it's from here, right? So from that region to 0, so you goes to 0, something like that, right? Now we have the last one, which is from 0 until 1. So for 7 pi over 4 until 2 pi is from 0 until 1. Is from 0 we want to go to this 2 pi, all right? So it starts from 0, it ends at 1, something like that, all right? This one should be a normal curve, right? Supposedly something like this, okay? You draw carefully, yeah? Right. So this is what we have when we draw r equal to cos 2 theta. We need to do one by one, right? Now we need to make a conclusion in general, right? If we have the polar equation in this form, which is theta is equal to k, where k is any real number in radian, all right, it should be a straight line, all right? So no matter what k values are, so it should be a straight line, right? So because this point the theta is k, at this point the theta is k, at this point the theta is also k, all right? Same goes to this part, because this one is the negative of the radius, all right? So we bear in mind, if we have theta is equal to any number, so it should be a straight line. If we have the r equal to k, where k is any real number, so this one should be a circle, okay? This one should be a circle, because if we have the radius 2, for example, so at this point the radius is 2, at this point 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 radius is 2, any point on this circle should be r equal to 2. So we have this circle, okay, this circle, all right? So this is the circle. And finally we have the cardioids. If we have the polar equation in form of this and also this one, we'll get the cardioid. We have shown one example on how to draw the cardioid, and you need to make another exercise. So this is the example for the cardioid, right? It looks like this, or this one, all right? So you have to try on your own how to draw the cardioid. So that's it. Thank you for watching.